Very briefly, I'm going to show you into my secret laboratory here behind my bookshelf. Yeah, as you can see, I've got some cool gear. It's a 3D printer I haven't used much. This is the newest one. Let's see here. Oh, this is gonna hurt the eyeballs. Whoa! Check that. Infrared. That is the near infrared, and oh my. And that, I don't know if you can see it. Ooh, that's still wrong button. A sec here. There we go. That's far infrared. You can probably see it. A little bit of a glow. I think I'm slightly blind. You're supposed to wear goggles when you're doing that kind of thing. But yeah, this is my you can feel the heat coming off of that. It's a 300 watt LED panel. It's got 300 LEDs. I guess they're a watt each. And that's a watt. So yeah, it's nice and hot. So let me briefly explain this here. This is a Van der Graaff generator. Okay, so what we have here, this is the metal base. You get the rubber band going up here. And the metal, there's no wires or anything like that. It's just literally the most simple thing. And something called triboelectrics, the rubbing of the I'll try to explain this in more simple terms than the full explanation, but the rubber band has a tendency, or whatever, it's made of rubber or silicone, it has a tendency to gain a negative charge, which means it wants to absorb electrons. Now, there's under here, see, it's as simple as just a roller, rubber band, you see it, and there's a little, this doohickey here, my terminologies are always terrible, the little pointy thingy that scrapes electrons off, so the rubber band pulls them from this metal ball here from the air, so the air's got more electrons, but yeah, it pulls it out of the metal. Where's the... Oh, great. 2 seconds here. Gotta fit that on top properly. Oops. Sorry about... There we go. Sorry about the noise. Yeah, so this ends up getting a positive charge at the top here. A disparity of electrons. And they get dumped down here at the bottom. So it keeps pulling them away from the top and dumping them at the bottom. And this creates a big field. Yeah, I'll show you myself get shot here real good. Where do I set this up? I gotta turn this off here. Let's see here. Yeah, that might be good. Let's see here. So this is gonna suck. I don't know if you'll see this part, but there's my wand here. Just a second. Where's the other piece? Yeah. I don't know where my I have to order some new cables because I'm using stereo cables here, and they're not high voltage cables, but they work. So I'm gonna connect this to the bottom. Now there's a wire, but it doesn't really count as you're not hooking it up to. I'm hooking up to the base, so this wand is now the negative terminal. So you'll see now that you see the electricity flying off of that. all I'm doing is turning a band, and now it needs its electrons, so it's ripping electrons off of here. All those electrons are dumping at the bottom, flowing up to here, and making their way back to balance everything out over here. So, the top is a positive charge, the bottom is a negative charge, and you can build that up pretty good. If I don't discharge that, just crank it for a while, just make that rubber band go around, it'll be an even bigger bolt, right? Well, you can get the Windsor is a little bit better, but I got a kind of a crazy setup going on here. This is the worst place to do electrostatic stuff. I put this metal stuff up here, and it's it's definitely causing all kinds of things. So what I've been talking about with the buildings is this is a church, you see, or a Capitol building, right? This is the steeple of the church, the metal roof, and the earth has a negative charge on its surface. So because this isn't connected to the base, and it's just floating in the air, sitting on insulators, it's not grounded. In the air, there's a few ways that it can start to gain a positive charge, right? There's a voltage gradient in the air. Every meter of height above sea level, the voltage goes up in the atmosphere. So at the height, I think the church here, that's the highest building in town, sits at 80 meters height above sea level. So the atmospheric voltage gradient is between 100 to 300 volts per meter above sea level. So at 80 meters, that'd be like 8,000 volts minimum. Yeah, and that's wild. So 8,000 to times that by 3, right? 24, whatever. Yeah, you get the idea. It's a lot of voltage, but no current. Everybody says, well, that's useless, though. There's no current. Okay, there's some crazy stuff now. When you have this all charged up and it can't go anywhere, and the Earth has a negative charge, in between there's field lines that form, invisible field lines, like a pull. It's like a magnet. The negative wants to pull towards the positive, or this wants its electrons back, and it's trying to get its electrons back. Yeah, this field that exists in between, if you keep that you don't want it to spark. With the old system, you don't want it to discharge. You don't want current. You want that wavy field in the middle. It's not wavy at first, but you can wave it. So if you dangle a little bell off the bottom of the roof and use it as an electrode as part of the electric terminal, that's one way where you can then have a static charge that's on the surface of the bell, and that the field lines between the base and up there are now wiggling. So if you got something in between there's a few things that can happen. That's my farm silo is the same idea, where this would be the metal dome of the farm silo. There would be concrete instead of these plastic bracers here. It'd be like blocks, right? Going all the way down. And when you have that field built up without the roof being grounded, all you need is a little bit of vibration, and you'll generate heat in there. It's called electrostriction, or dielectric heating, actually. Electrostriction is slightly different, but it's kind of to do with that. So yeah, that's part of it. I wasn't really planning on doing a video, actually, but I just figured, I'll do it by fly. I forget what video. I got a lot of work to do, right? We started this mystery guild thing. I shouldn't say thing. It's we got a pretty awesome team growing, and more people are joining up. But I need some corroboration, what we're going to do is we're going to go to some of the churches in town. I need to get information. What bell frequencies are, heights of everything. But no matter what, whether they design the churches or these other buildings to accumulate or use atmospheric electricity, which is ever present, they'll work that way. They're just built that they'll work that way, whether they meant to or not. And like all the spikies at the top of the finials on top of these spires concentrates voltage even more than the 100 to 300 voltage gradient. It greatly increases it. So if you look up an effect called St. Elmo's fire, that's something that Navy guys will probably know of more so than most people. Yeah, it's like electric corona discharge at the top of ship masts. And that's part of what you see with all these churches. You'll see the tops of the spires are all black, and now people will come up with all kinds of silly things. Oh, that's just bacteria, or that's just this or that. It's like, why is it only on the spiky parts of that? Like, no, it's definitely from atmospheric electricity flowing. Like the electrons want to flow up to the highest objects until they, eject into the sky. In a thunderstorm, the ground actually becomes positive, and all those electrons are ejected to the bottom of a cloud. So the ground actually takes on a positive charge while there's clouds in the sky. But when it's clear out and nice, the ground is negative charge, and the sky is positive, increasingly as you go higher into the air. So yeah, if you have like a metal disc with like an insulator over top of it and just stick it way up in the air, it's going to accumulate quite a bit of charge, and eventually it wants to get its electrons back. But while it doesn't, it's able to do some interesting things. You're able to manipulate that electric field in a way that isn't really on the radar of most electrical. See, most modern electrical engineers are kind of trained to get rid of static electricity. It's undesirable in all modern systems. I'm running some danger doing this in here. I need like a electricity-less farm with a silo, all that kind of stuff, that I can do some real experiments, larger macro scale of some of these little things, because all the science is there. I know that. But to get that real voltage gradient, that atmospheric voltage gradient, you need to go big. You can't do that on the ground at less than a meter. It's 50 volts isn't going to do what we're looking for. So I'm kind of going all over the place here, but I'll do actual real videos talking about stuff at some point soon. Better explanations for things and adventures going to some of these churches, because yeah, this is wild. That doesn't even scrape the surface of some of the stuff. If we go in process here in sequence the way I have it planned out, then it would be awesome. But I feel like everything's going so slow. Funding is going to be slow to come in. I still have to survive, So, and yeah, just like anybody, right? But I put this is what I put my money into. I don't go on vacations. My car's broken right now. All that salt from Canadian winters. So yeah, I have a lot of work to do anyway. That's bottom line. But I thought I would just do a general little explanation of some of that stuff. I'm also obviously into the alchemy stuff, but as you can see, it's pretty clean in here. I haven't done much of that. I just have so much on the go. Sorry, I just gotta close my secret bookshelf door here to the secret lab. There we go. And girl. That's Lulu. Yeah, so yeah, that is that's what we're doing here. Look at that giant wheel. They don't even use the cat wheel. Fat cats. Okay, well that's enough. I'll leave you with this awesome view of St. John. That's my back window here. Woohoo. Excellent. Alright. Rock and roll. I'm going back to the old back to the office here. Oh, I might as well take you for a tour up here. It's quite a large house. Kind of looked out pretty big. Yeah. Back to way up here. Yeah, so a lot of work to do. Eventually, we'll get our mystery guild patches going here again, but I busted my machine. So I got all kinds of stuff on the go. The biggest one is the Electro-Archaeology. We're doing that through the Mystery Guild. We're also going to have a lot of adventures going through the Mystery Guild. That was the original plan. I was kind of avoiding the Electro-Archaeology thing and combining it with the Mystery Guild, but it was inevitable. It's the only way to make it sustainable for myself. I didn't want to do that as a backup project if I can incorporate it all together. And there's enough churches and buildings here where I think I can do, as long as I have cooperation, because there is an element that is not a fan of old Alexander Stone. So I've probably pissed off everybody at some point, for good reason. I stand by everything I've said, almost. I've corrected myself on a lot. And you all need to do some correcting too. The ones that are giving me a hard time. but yeah, we'll do battle at some point, hopefully on camera, and it'll be glorious, but in a good way. It's got to be productive. That's all I really care about, is getting this stuff going. Anyway, I'm just gonna blab all night. Oh yeah, there's the other cat there. Ava. What's that? Can't say adios. Yeah. Actually, what I should be doing before I go, turn studio to white. This is the other. Should be rocking and rolling, right? That was where I started this crazy thing. And you see them. See these glasses? You like those? Talk about that another time. Let's see. Alright. Long live rock and roll. Power to the people. All together now. Yeah. Have a good night. Bye-bye.